Hello there, Mr. Chen here for Algebra 1. We're about to start a new section, 7-7, Factoring Special Cases. Grab your note takers and turn to page 163, and let's get started. I'm actually going to skip the opener between Seth and Bailey. I'm going to use the white space here to kind of remind you of what kind of special cases that we had back in 7-3. We are actually going to go backwards of 7-3 in this section today, the last section of this chapter. In 7-3, we learned about something called the perfect square trinomial. I'll sometimes refer to this as PSTs. To create a perfect square trinomial, you might have had an example like this. Take a binomial, such as x plus 3, and square it. When I say square, it literally means take it and multiply by itself. So this might have come from easily x plus 3 squared, which means that. Just a quick reminder, x plus 3 squared is not x squared plus 3 squared. You have to expand and FOIL. So when we FOIL this, we will get x squared for the first terms, 3x for the outer terms, 3x again for the inner terms, and 9 for the last terms. And when you combine them all together, especially since you recognize the middle two terms are like terms, you'll get x squared plus 6x plus 9. That is a perfect square trinomial. And what kind of patterns do we see if we were to apply to this section, 7-7? We're going to go backwards today. The key is to recognize that this quadratic is a perfect square trinomial. How do we do that? A quick check is to look at the first term and square root it, the number. 1x squared, technically, x squared. Okay? And after you square root that one, you want to square root the last term, the constant by itself. And after you square root those things, those terms, you want to multiply them together, in this case, x and 3, and double it. Meaning multiply by 2. When you multiply them together and double it, this is a quick mental check here. So x times 3 times 2, you'll get, 6x. And that is, ladies and gentlemen, the middle term. It checks. The middle term is bx. And if it's that check works, that means it is a PST. So that is basically what this whole section is about. Now, it's not the end of the world. Let me tell you now. This section is not something you have to memorize, but recognizing it, really will shorten your work on it. You can always go back to the last section, the hybrid box AC method, and that's fine too. So here we go. We are going to look for, let's go ahead and go to the next page. We're going to look for a perfect square trinomial, and we're going to look for a pattern. Square root the first term, square root the second term, last term, multiply them together or double it. If you don't see the pattern, you can always use the AC hybrid box method. It doesn't really matter, this section, if you don't want to memorize it. So just a quick reminder what those patterns look like. Write this down. If you take a binomial and you square it, you'll get a squared plus 2ab plus b squared. Notice that 2ab right there is doubling the product of the square root of the terms on the end. See that ab right there? That means the square root. We also have a pattern for subtraction that we can look out for as well today. And there it is, okay? Hey, let's try that and check number 1a. Here we go. Zoom in a little bit more. Very good. Ooh, this is a possible PST. Let's square root the first term. Square root of 4x squared is 2x. Let's square root the last term. Yay. Let's go ahead and multiply them together and double it. When we double it, we will get, let's check, 2, 3, and 2. 2 times 3 is 6, times 2 is 12x. Yay, there it is. Ding, 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 ding. It matches the middle term. That means this is a perfect square trinomial, means you can factor it. And it becomes literally what we just got a second ago, the 2x and the 3. Go right here. It's all positive, very good. So this is simply 2x plus 3 squared. So either one of those are acceptable for an answer when it comes to factoring. Just a quick reminder, when you look for the patterns for a PST, it's the signage are plus plus or minus plus. Keep those in mind when it comes to those quadratics. Plus plus or minus plus. I'm referring to right here. Plus plus minus plus. Okay? All right, let's try another one. Here we go. Zoom back out a little bit so you can kind of see everything a little bit. Let's do it. Square root the first term. Nice. Square root the last term. Go ahead and double it after you multiply. Good. When I do that, I get 8x. It matches. Ding, 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 ding. Be careful though. I know I have 8x right there. Note the minus sign, minus plus. So when you put it into a factored form, be sure to include minus minus, okay? With the x plus 4. x4, when we square rooted those things, make sure you put the minus there. And there's my answer. You can group them together, that's fine. And you can write it that way, okay? Wow, not too bad. So this is basically this whole section, checking to see if it's a special case, in this case, a perfect square trinomial. Let's skip example 2 and move on to the next problems. All right, so these are my favorite. This is a special pattern for something called difference of two squares. Okay, difference of two squares comes about when you, and this is from back in 7-3, if you multiply a positive and a negative, or I call them conjugates, they're called conjugates. If you FOIL this, and I'll just reprove it to you, no big deal. When you multiply this is called the product of a sum and difference here. The inner and the outer terms cancel, leaving you with a squared minus b squared. This thing right here is called a difference of perfect squares, or two squares. If you have a binomial. These are the characteristics. It's a binomial, right? This thing right there is a binomial. And there's a minus sign right there. And the terms are square rootable. Then you have a difference of two squares. That is the pattern. This is one that I would rather you learn more than anything else in this section. Difference of two squares. Let's take a look at 3a here. All right, let's check. Is it a binomial? Yes. Meaning two terms. Is there a minus sign? Yes. And finally, are the terms square rootable? Let's see, the square root of x squared is x. The square root of 64 is 8. Yay, ding, 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 ding. This final answer is x8 minus plus or plus minus, doesn't matter which order you put it in. And that's it. This is something you should know for your future math classes, okay? Let's try 3b. We have a minus sign, nice. It's a binomial, nice. And the terms, let's see, 9 and 100, yeah, those are square rootable. Yes, the square root of 9x squared is 3x, and the square root of 100 is 10. Yay, ding, ding, ding. This is a difference of perfect squares. Put those there. Put a minus plus, and you're done. These are really fast. So those are the basic types of special cases. Number 4 just deals with more on top of those things, including a common factor. So it's just a little more, no big deal. Here we're looking for a GCF before we apply any patterns and stuff like that. Look at this particular problem right here. I mean, you can use a box if you want to, or just take out a GCF here. Let's do that, okay? Hey. 4x cubed and 24x squared and 36x. I could definitely see an x right there. Here and here I can take out. Nice. And the number 4 can be divided out from those three terms as well. So 4x is your GCF that we're going to divide into those three terms there, okay? So when we do that, it uncovers a polynomial that can probably maybe factor further. So that's the point of this section, right? This particular problem here. So 4x cubed divided by 4x is x squared. 24 divided by 4 is 6x, because the x squared divided by x is x. And then finally 36 divided by 4 is 9. The x's go away. Ooh, interesting. Look at that thing. That looks kind of familiar. Is that a PST? Might be. Let's check. Let's square root the first term and the last term. And double it, right? Let's see. X times 3 times. Oh, yay. That is 6x. The middle term. That is a PST. Very nice. So that means, let's write this down now. Hold on. 4x from earlier. And the PST, the perfect square trinomial, factors to x3. Do a different color here. x3, x3. All positives, positive, positive. And there's your answer right there. And you can shrink it up if you like to. Like that, okay? Not too bad. It's like a club sandwich versus a regular sandwich. There's a lot of layers here. How about this one? This binomial, interesting. 50 and 32, can I make that smaller? Huh. I can pull out a 2, I think that's my greatest common factor, but nothing else, no variables. So if I take out a 2, that leaves me with a 25x squared minus 16y squared. Interesting. It's a binomial, so it's not one of those PSTs. Is it a difference of two squares? Question mark. All right, let's check. Nope, there's a minus sign. Very good. It's a binomial, And are those terms square rootable? And they are. The square root of 25x squared is 5x. The square root of 16y squared is 4y. Bam, bam, yay. This becomes 2, 5x, 4y, 5x, 4y, 5x, 4y. This is a difference of squares, so the signs are minus plus. There's your answer. You can't group them together, they're not the same. Hey, not too bad. You guys ready for the last page? We'll skip this habits of mind here. The last page is just a bunch of the same stuff. Is it a binomial? Is it a trinomial? If it's a trinomial, is it a PST? Blah, blah, blah. Let me zoom in a little bit more. Oh, number 6 is definitely a binomial. Is there a pattern? There's a minus sign. It's a binomial. Very good. There's not a lot of space, so I have to be careful here. 4x squared is square rootable. Nice. 9 is square rootable. Hey, there it is. So that means this becomes, this is a difference of perfect squares though. Yay. Ding, 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 ding. So that is the pattern. 2x3, 2x3, minus plus. Okay, that is the answer. Very good. So that's what we're looking for when it comes to patterns. Is it a PST or difference of perfect squares? Perfect square trinomial or difference of perfect squares? All right. Oh, number 7 looks very familiar. We just did that a moment ago. Is it a PST? Let's check. First term is a square rootable. Last term is a square rootable. What happens if we double it? That becomes 6x. Oh, yay. Ding, 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 ding. There it is. 6x is the match. That matches. Yay. So this is a PST. It's x3, x3, positive, positive. Now, all the stuff that I'm doing can be put into a AC hybrid box. It's not necessary. It actually requires more work, but if you notice a pattern, it's much faster. All right, let's try number 8. Let's check to see if that is a PST because it's a trinomial. All right, you guys ready to check? It's a minus plus. So if this was a PST, it would be a minus minus when you factor it out. So let's check it out. The square root of 9x squared is 3x. The square root of 4 is 2. And if we multiply it and double it, let's see what happens here. 3 times 2 times 2. Oh, is 12x. Oh, yay. Matches. Yay. So this is a PST. But this time it's minus minus. And there's your answer. And you can group them together. I forgot to put that too. You can group number 7 as well. So I'll put that too. Okay. How are we doing out there? It's not a long section, but it's kind of cool to recognize these patterns. It really is. Saves you a lot of work sometimes when you're trying to factor a bunch of stuff in the future. Okay. Number 9. I can't square root 5. I can't square root 45. So something's going on here. Oh, I need a GCF first. Interesting. 534. Oh, I could take out a 5. Very good. Which means that leaves me with x squared. Let's see, 30 divided by 5 is 6. 45 divided by 5 is 9. That looks like almost like number 7, doesn't it? But there's a minus plus here, literally. So that means, is it a PST? And it is. As you can see, the work from number 7 is going to be the same as here. The square root of x squared is x. Square root of 9 is 3. When you double it, you'll get the 6x in the middle. So that means not only do I have a 5 on the outside, I do have an x3, x3, but because of the minus sign, minus plus, it's going to be minus minus right there. And there's your answer. Of course, you could consolidate that, of course, make it look nicer like this. And that's allowed too. All right. Very good. The rest of this is just a lot more, okay? Maybe we should let you guys try one on your own. I'll let you try number 10 by yourself. Before you do number 10, though, I will warn you, you can actually factor out a 4. So try number 10 by yourself, and I'll be quiet. Whew. Interesting. I did find a difference of squares after I factored out a GCF for number 10. And from there, I broke that up based off of square rooting, the first and the last terms, minus plus, and there it is. Yay. Number 11. Looks like another GCF. Can't square root of 3, so possibly, yeah, take out a 3. Let's see what we can get there. Interesting. I do have a possible PST. I'll let you guys work on it on your own. There's a lot of practice. Looks like it matches. Yay. It's a positive positive. How are we doing out there? They get a little harder, definitely. I'm going to keep going. Ooh, number 12. Check your answers for number 10 and 11. Let me know if you have any questions. Number 12 is a possible difference of squares. This is extra practice. Yeah, there's a minus sign. Yay. 49x squared is 7x. That's square rootable. 25 is square rootable. Oh, yay, there it is. Yay. This is minus plus. Well, this isn't too bad. Ooh, number 13 is big numbers there. Can I take out a GCF here? Let's see, what can I take out here? Big number going to 4, maybe? Yeah, that's possible. Let's take out a 4. That's it. Let's check to see if it's a PST. Let's check the square root here. Square root of 9x squared is 3x. Square root of 4 is 2. Let's double it and after we multiply it. Ooh, it works. Lucky us. You have to remember, these are special cases. And not everything works like this. Just keep an eye for your PSTs and difference of perfect squares. In this case, it's positive, positive. There's your answer right there. And there's your alternative. Either one of them is correct. Woo. Any questions on 12 and 13? Yeah, I'm just going to keep going. Might as well. Oh, looks like I can take out a big GCF for number 14. Looks like I can take out a 3 as well as an X this time on all of them. That leaves me with an x squared minus 4x plus 4. Yep, definitely a PST, because when you square root x squared, you get x. When you square root of 4, you get 2. When you double it, you'll get the 4x, which matches the middle term. Now be careful here. This is a minus plus, which means my answer will be minus minus with the x and the 2. And there's your answer right there. You get used to this after a while. You got to practice though on your own. You can't just watch me all the time, all right? And there it is. Hey. Whew, almost done. 15 is a binomial. Can I squeeze out something from that 72 and 32? Oh, multiplication tables are important here. Take out a, let's see, 2, 3, 4, 5, 6, nope, 7, 8. 8 works? Oh, wow, that's crazy. Take out an 8. That leaves you with 9x squared minus, oh, there it is, difference of squares. Let's check. There's a minus sign, square rootable. Yeah, definitely. Oh, yay. There it is. It works as a difference of squares. It's a minus plus. Can't consolidate those, right? That's your answer right there with that GCF. All right. Any questions on 14 and 15? I think we are ready for the last one. This is an interesting visual problem. What is the side length of the square shown below? They literally tell you this shape is a square, meaning the lengths are the same. Something times itself is x squared plus 22x plus 121. And if you do a quick, because it is a PST possibility, if you square root the outer terms there and you double that product, you will get 22x. The middle term right there. So it is, ladies and gentlemen, the lengths are x plus 11. There's your answer right there, okay? Yay, that is your side length. Thank you very much. We just got it under 30 minutes, not too bad. See you next time, thank you, bye-bye.